let's solve some more rational equations. So let's say I have x plus 1 over x is equal to 2. Once again, we have an x in a denominator over here. It looks kind of bizarre. But you just have to remember, if we multiply every term in this equation by this denominator right here, by this x right there, then it'll essentially, you'll have x times 1 over x, and the x will disappear out of the denominator. So let's do that. So we have to multiply every term by that. You can't just multiply one term. So multiply this term times x, this term times x, and then the 2 times x. We're just multiplying both sides of this equation by this denominator. So what do we get? We get x times x is x squared plus x times 1 over x is just 1. X's cancel out. And then that's going to be equal to 2x. That's going to be equal to 2x. And this is starting to look like our standard quadratic equations. We just have to subtract 2x from both sides. And if we do that, so let me subtract 2x from there, subtract 2x from there. The left-hand side of our equation becomes x squared minus 2x plus 1. And the right-hand side is equal to 0. And we know how to solve an equation like this. We can either factor or use the quadratic formula. But this actually seems pretty straightforward to factor. -1 times -1 is 1. -1 plus -1 is -2. So this is x minus 1 times x minus 1 is equal to 0. And we know if two numbers, when you multiply them, they equal 0, that means one or both of those numbers have to be equal to 0. In this situation, the number is the same, right? This is x minus 1 squared is equal to 0. Right? So we know that x minus 1 has to be equal to 0. Add 1 to both sides of this equation, and we get x is equal to 1. And you can verify it. Verify that this works. Verify that this works. 1 plus 1 over 1 does indeed equal 2. So it definitely does work. Let's do a more involved one now, now that we're warmed up. Let's say I have 2 over x squared plus 4x plus 3 is equal to 2 plus x minus 2 over x minus 3. So just like we've done in the last problem and in all of the other ones, we want to get all of these x's out of the denominator. And the best way to do it is to multiply every term in this equation by, you can view it as the least common multiple of the denominator. So let me show you what I'm talking about. The first thing we might want to do is factor this to see if this guy and this guy have anything in common. So let's see if we can factor it. What two numbers, when you multiply them, equal 3, and when you add them, equal 4? Well, 3 and 1, right? So this right here, I can rewrite it as x plus 3 and x plus 3. And oh, and really, this is a plus over there, too. I wrote the original problem wrong. That is a product. So this over here on the left is x plus 3 times x plus 1. And so what can we multiply both sides of this equation by to get rid of the x plus 3 and an x plus 1 here and an x plus 3 over there? Well, we multiply everything by x plus 3 and then by x plus 1. So this expression right here is actually divisible by this. So the least common multiple of x plus 3 and x squared plus 4x plus 3 is actually x squared plus 4x plus 3, because this is a multiple of that. It's divisible by it. So let's multiply both sides of the equation by this expression right here. So we're going to get, let me just rewrite it, x plus 3 times x plus 1. And then we have this term over here times 2 over x plus 3 times x plus 1 is going to be equal to x plus 3 times x plus 1 times this 2 times that 2 over there plus x plus 3 times x plus 1 times this term times x minus 2 over x plus 3. Now, the whole reason why we did that is because that will cancel with that. The left-hand side of our equation will just be a 2. And 2 will be equal to, well, 2 times this. 2 times this. We know what this is equal to. X plus 3 times x plus 1 is x squared plus 4x plus 3. We know that. We actually went the other way. We factored it. So it's going to be 2 times x squared plus 4x plus 3, which is 2 times x squared is, let me do it in that green color so you know we're dealing with this 2 right here. So this term right here is going to be 2 times x squared. So it's 2x squared plus 2 times 4x plus 8x plus 2 times 3 plus 6. And now this term, we have an x plus 3 in the numerator, or it would be if I multiplied it times this fraction or this rational expression. That x plus 3 will cancel with that x plus 3. So we're just left with an x plus 1 times an x minus 2. An x plus 1 times x minus 2. Let me just focus in on this expression right here. X plus 1, well, I'll just box the whole thing. X plus 1 times x minus 2 is, let's just say it's x times x, which is x squared, x times negative 2, which is negative 2x, and then you have 1 times x, so plus x, and then you have 1 times negative 2, so you have minus 2. And now we can simplify it. So once again, the left-hand side of this equation is still 2. Now on the right-hand side, let's look at the x squared terms. We have a 2x squared and we have an x squared. Add them together, you get 3x squared. Then we have an 8x and we have a minus 2x plus x. So what's that going to be? This is an 8x, and then when you add these together, you just get a negative x. So when you add everything together, you're going to get a plus 7x. Plus 7x, those are the x terms. And then finally, you have I already used the orange. You have a 6, and you have a minus 2. So that's going to be plus 4. And now let's subtract 2 from both sides of this equation. Let's subtract 2 from both sides. And we are left with 0 is equal to 3x squared plus 7x. We are subtracting 2 from both sides. So 4 minus 2 is plus 2. So we've turned this bizarre looking thing into kind of a standard plain vanilla quadratic equation. But we have a non-zero coefficient out here. We just want to solve for it. We actually don't even have to factor it. So we might as well just use the quadratic formula. That's the easiest way to solve, especially a quadratic equation that has a non-1 coefficient on the x squared term. So our solutions using the quadratic formula, x is going to be equal to negative b, which is negative 7, plus or minus the square root of b squared, that's 7 squared, which is 49, minus 4 times a, which is 3, times c, which is 2. All of that over 2 times a. Over 2 times 3 is 6. So what is this equal to? 4 times 3 is 12, times 2 is 24. So that right there is 24. What's 49 minus 24? What's 25? 25. So I don't want to make that too messy, so let me rewrite it. So x is equal to negative 7 plus or minus the square root of 49 minus 24 is 25 over 6, which is equal to negative 7 plus or minus 5, the square root of 25, over 6. And let's see, if we were to add 5, that'd be negative 7 plus 5 is negative 2 over 6, which is equal to negative 1/3. That is one solution. And then if I do negative 7 minus 5, that is negative 12 over 6, which is equal to negative 2. So those are our two solutions to this original rational equation right up here. Hopefully you enjoyed that.